Hello and welcome to Walking Talking Mocks with Budehaven Science. This video is going to look at electrolysis. We will cover the subject knowledge needed to answer an exam-style question. You will then be given the opportunity to answer an exam question, followed by an example answer from me. Here is the exam question. In order to answer this 6-mark question, you will need paper, a pen, and something to time yourself with. To answer this question, you should have a good understanding of the products formed during electrolysis. The term electrolysis can be broken down into two parts, electro and lysis. Electro meaning electrical and lysis meaning to loosen. So we're loosening or breaking using electricity. So in simple terms, we're using an electrical current to break down ionic compounds. To fully explain the process, you should be able to label the parts of the equipment. See the diagram I've provided. It is important that you get the names of the electrodes and ions correct. But if in the exam you cannot remember, just say the positive and negative ion or electrode. It may be helpful for you to remember that the ions and electrodes that come together have the same name. For example, cathode and cation. Because of how we look at language, there may be a misconception that because they have the same prefix, they have the same charge, but this is not the case. The ions move through the solution and collect at the electrode with the opposite charge to themselves. So for electrolysis to take place, the ions in the compounds must be able to move. If we use copper sulfate as an example, as a solid, which are the blue crystals you may have seen before, the charged ions within the lattice cannot move. This means that as a solid, it cannot conduct electricity and therefore electrolysis cannot take place. Therefore, if you'd like to use copper sulfate for electrolysis, you must do so in molten state or as an aqueous solution. In both of these states, the ions are able to move. This makes them able to carry electrical charge. But more importantly, because the ions are able to move, we can break apart the ionic lattice and form a desired product at the electrodes. In this case, it would be copper. To answer the more challenging electrolysis questions, you need to recall the rules for what forms at the electrodes. The more basic question might ask you to use molten ionic compounds as an example. This is more simple to answer as the only ions present in the beaker would be the metal and the non-metal. Remembering that in an ionic compound, the metal will always be positive due to the loss of electrons from the outer shell. The non-metal is therefore always negative, as this will have taken on the electrons donated from the metal. What this means in terms of electrolysis is that the metal is the cation and moves to the cathode. The non-metal is the anion and moves to the anode. The idea becomes more tricky when you need to determine the products that will form when an aqueous solution is electrolyzed. The reason it is more complicated is due to the presence of the water molecules. During electrolysis, the water molecules split into H+ and OH- or a hydroxide ion. Their charge causes them to move to the oppositely charged electrode. So if we use the example of a sodium chloride solution, we can see that present in the beaker is H+ and Na+. These are both cations, so move to the negative cathode. There is also OH- and Cl-. These are anions, so both move to the positive anode. The products that form at each electrode in an aqueous solution depend on a few factors. Earlier I referred to these as rules. This is because there are set criteria for what forms at the electrodes depending on reactivity and the presence of halide ions. A halide ion is any halogen, which is a group 7 element, that has become an ion by gaining electrons. So if it is possible for two elements to form at an electrode, we need to be able to determine what will form. The rules for each electrode, when more than one element could be formed, are as follows. At the cathode, we would expect all of the positive ions to form there, so this would be the metals and the hydrogen ions. The least reactive of these will form. It is most likely to be hydrogen forming, as there are only a few metals less reactive than hydrogen. At the anode, it is slightly more complicated. If there is a halide ion present, such as a chloride, then this will form. If there are no halides, the hydroxide ion will form, by producing water and giving off oxygen. In the event that there are no halides or hydroxides, the other negative ions will form as elements. The final thing to look at is how the elements form at the electrodes. When moving through solution or a molten state, they are ions. This means they have either lost or gained electrons. Therefore, in order to form as an element at either electrode, positive ions must gain electrons to neutralise their charge, and negative ions need to lose their additional electrons. You might remember that when an ion loses or gains electrons, we have names for the process. When electrons are lost, it's called oxidation. When ions gain electrons, it's called reduction. OIL-RIG is our acronym to help us remember which is which. This stands for oxidation is loss, reduction is gain. The other part of this you need to know is the half equations. These look at movements of electrons from the electrode to the ion, or the ion to the electrode. So if we use the example of copper sulfate solution, the copper ions have a 2+ charge, meaning there are 2 less electrons than there should be. The sulfate ion has 2 more electrons than there should be. So for the copper to form, the ions need to gain 2 electrons from the electrode. As we know, atoms of elements are neutral in charge, so when the copper gains electrons, the atoms become neutral and the metal lattice can form. This reaction can be shown using a half equation. This is an equation where we show the movement of electrons. So in this case, we can show that the copper ions will come together with 2 electrons to form 1 copper atom. The state symbols should also be included. Remember that the copper ions are in an aqueous solution. At the anode, there are no halides present, so the oxygen from the hydroxide will be given off. To do this, the hydroxide needs to lose its additional electrons to form water and oxygen. So on the reactant side, we can show that the hydroxide ions at the electrode lose electrons, so oxygen is given off and water remains in solution. For oxygen to form, it will be released diatomically, so we need 2 atoms to form. This needs balancing to be correct, so here is the balanced equation. Over to you. Here is your exam question to try. In a moment, pause the video for 6 minutes and attempt your own answer. An example answer will follow from me. The command word here is explain. This is a high demand question as it requires you to give reasons for what's happening. Pause the video now. So when I read the question, the first thing I think of is stating why the ions move, ensuring I say ions because of course the atom wouldn't travel. Then I would need to state what happens to the ions when they get there. So here are my 3 points for each question. If you're still struggling with this topic, please see your teacher or come to one of our Wednesday revision sessions.